Hello, and welcome to the second video in the series covering the simulation process for SAE racing teams. Video 2 will discuss the meshing process for 1D and 3D meshes, and will explain further which simulation would work best for teams depending on their needs and capabilities. I would recommend considering this entire video before going back and watching the relevant tutorial in order to compare the results from each type of run and help you decide which path is right for you and your team. For this video, we'll start in the part file, but we'll work predominantly within the FEM file. I'll first demonstrate how to set up a 1D mesh for your car geometry. This is what you'll most likely use as your baseline simulation, or if you're short on time, can be sufficient for car design on its own, with higher factors of safety baked in. The first thing I want to do is make sure that I'm in the pre-post application to start. I also want to make sure that I'm in my top level of my assembly to choose the geometry from. For the 1D solution, we can hide the model we created in the last video so that we can only see the 1D geometry. Next, I'll want to create a new FEM and Sim. I'll want to make sure that I have the Create Idealized Part checkbox checked if I plan on making any design iterations to the geometry later. That way, I'll have an associative copy for the FEM and Sim to reference, as well as the original part unchanged. And I'll be very careful to specify that I want to bring in points and curves. Otherwise, the FEM won't house any curves and it'll only bring in the solid geometry. Once I've pressed OK and waited for the FEM and Sim to be generated, I'll enter my solution name. For this example, torsion test, and we're doing it on a 1D model, so torsion test 1D. I'll press OK to everything else default in this menu. The next thing I'll do is get rid of any extraneous sketches that aren't a part of the 1D chassis model that I'd like to mesh. I'll do this using the show hide command. Afterwards, I'll create a 1D mesh. I'll simply use a click drag box to select all of my lines, making sure to deselect any curved lines, as those will have to be designated to a different mesh collector. I'll create a C-bar element, give it an element size I think is reasonable, and make a new mesh collector to represent the beams. Within this section dialog, I can make sure I have the cross-section for beams so that this 1D mesh represents 3D geometry. I'll simply enter the correct external and internal radii, assign a material property, and press OK on all the dialogues. Now that I've finished all the straight members in the mesh, it's time to move on to the curved pieces. What I need before I can mesh these pieces is the radius of the bend curvature. And to do this, I'll use the measure tool by searching for it in the command finder, or it can be accessed through menu and analysis. I can use this tool by just clicking on the curves that I want to know information on, and it'll give me the curve radius. This radius is 3.23 inches. Conveniently, this radius is the same. And this curve radius is 5.87 inches. So once I have taken note of those values, I can come in and create another 1D mesh. I'll be sure to select all the curves of a single radius. Choose an appropriate element size, and change the element property to C-bend so that it works on a curved line. Now I'll enter my pipe properties, including material, inner diameter, outer diameter, and the bend radius we took note of before. Once that's done, we'll do the same process for the two of different radius above. The dialog box should remember all the values entered previously, so you should just have to change the bend radius. The next thing I want to do is just make a quick visual check that our mesh looks right. So I'll come into File, Preferences, Mesh Display, and I'll turn my display section to solid and hit Apply. From this I can see it looks like I entered all the correct radiuses, and this resembles my 3D geometry. So I'll turn it back off and feel confident that our mesh is correct. However, I also know that our straight and curved meshes aren't actually connected. So, to resolve this, I'll use the duplicate nodes command. Once again, I'll use my box select to select everything, and it'll essentially take where the endpoint of the curved lines and the endpoint of the straight lines, where they're coincident, and combine them so that the mesh is one cohesive thing. At this point, our entire chassis is actually meshed. The only thing we need to do is create additional nodes to apply our constraints and loads to, as well as connector nodes to connect where we're applying those forces and constraints to the chassis itself. To do this, I'm going to create 4 nodes, which will essentially act as the center of mass for the tires, and create 1D connection nodes to connect that point to the chassis, where the 4 suspension struts would be placed. Now that I have my 4 nodes created where the center of my tires will be, at this point I will create the 1D connection nodes. For this, I'll maintain a node-to-node connection, and I'll select the 4 node locations where I want to connect to the chassis, where the suspension would ideally connect in real life. For the back 2 connections, I'm going to choose to use a RBE2 type element, and this type of connection gives infinite stiffness. For the front 2, I'll be using a RBE3 element, and this does a better job of transferring forces to the model, which is good because this is where we'll be applying our forces for the torsion test in the next video. And with that, our model is fully meshed and we're ready to move on to the 3D case. Preparing 3D geometry for simulation is going to be mostly the same, and actually the meshing process in this case will be a little bit easier. We'll start off by creating a new FIM and sim, and in this case we don't actually have to bring in any lines, but we'll make sure to bring in point geometry because that's where our connection nodes exist. For the solution, I'll indicate the same name, and this time I'll indicate that we're doing it in 3D. I will also, within the Solution Manager, go to the Bulk Data section, edit my parameters, and turn on Auto MPC. What this does is it allows me to assign RBE2 and RBE3 elements, so that the order I select the nodes in doesn't matter, and the solver will instead intuit my pick and run. And actually, I realized I forgot to enable Auto MPC for the 1D run, which I would still want to do. Luckily, in the next video we can do that instead, as we'll be in the sim. For now, I'll work on meshing this 3D part. First, I'll create a 3D tetrahedral mesh and select my body. Once again, I will select a element size I think is appropriate. Usually I trust the lightning bolt, but to be conservative, I'll about cut it in half. Next, for the surface meshing method, I'll specify that I want to mesh from facets. This is a more robust solution, and since we have a complex faceted piece of geometry, I think this will work out better. And for that, I'm going to turn off small feature tolerance so that way it doesn't edit the geometry. I'll make sure I select a material, in this case steel, and press OK. This meshing process took 3 minutes and 13 seconds. I get this error message which indicates a few elements failed. So what I want to do is come up to my element quality check, select my body, and create a report of the failed elements. This will highlight which elements were problems. This test took 43 seconds to run and let me know that I had 6 elements fail. I can very easily see this group by turning on See Through All. If it doesn't appear in your top border bar, you can search it in the command finder. Since there are only 6 failed elements, and since they're not in exactly key locations, I'm actually just going to choose to ignore them. If you have a large amount of failed elements, you'll most likely want to refine your meshes by playing around with the settings in the meshing dialog, or edit the geometry so that it's cleaner. Now that the chassis has been meshed, we'll move on to the 1D connection nodes, as in the 1D example. Since it's 3D geometry, I'm going to use a clip section to hide part of the chassis so that I'm not selecting nodes on the other side of the chassis and making sure I'm only grabbing the ones I want. Another thing I'll do is make sure that I turn those points reflecting the center points of the tires into nodes so that I can create my 1D connection nodes, as we did before. Now I can use the nude points I created as well as the clip section to grab a hold of nodes where the chassis would connect to the suspension. I'm also changing my selection to be a circle rather than a box select. This makes it easier to grab the nodes at intersections to be a better reflection of how the suspension would be held on in an actual model. This is of course a very low fidelity way of modeling this. If I were to spend a lot more time on this model, I would model the geometry for how the suspension actually joins the chassis, and I would include my boundary conditions and loads onto that geometry. A way I could slightly improve the fidelity would be to use the split face command so that I'm applying these constraints and loads on the outward faces of these and not grabbing the internal faces of these beams. For a first pass of this kind of simulation on this model, however, this is perfect, and with that, we're actually finished and ready to move on to the simulation.